So, extra excited for this next session. So for the first time we've ever done this, actually I think it's really the first time ever industry-wide, we're getting all 4 WebRTC browser major WebRTC browser vendors up at the same time. So the format we're going to follow here is we've asked each one of the browser vendors to basically give a 5-minute lightning talk, just update notes for the developers out there, and then we're going to follow that up with a panel discussion. All right? So just to save time, I'm not going to introduce each individual speaker. I'm going to ask them to do that themselves, but let's start with Microsoft.
How's everybody doing? My name is Greg Whitworth. I am a senior product manager on Microsoft Edge. I don't know if you guys realized recently we updated our logo, so I decided I'd go ahead and show that. Yeah, over the past year, basically they asked us to update everybody over the past year, just in case nobody's aware. We're moving over to Chromium, so that's actually what the Edge team specifically has been primarily focused on. I don't need to spend too much time on it, but one of the primary reasons to move to Chromium is we hear from a lot of web devs, interop is a pain point. That's one I'm very passionate about and very excited about, so that we can actually focus on start solving other problems, daily builds, going to other operating systems. Hopefully we can get rid of IE. Stable releases every 6 weeks. Basically, we have an expectation of all the platform changes we do to be upstream by default. We don't want to have that divergence. Again, interoperability is very important to us. That said, we did do a lot of work. For example, in media, we still do dual DRM support. Basically, we have it in hardware accelerated format with PlayReady. It gives us a lot of battery benefits that Widevine does not, as well as it allows some of the major streaming partners, since it's more secure, they service higher quality content. We do have also Dolby Vision and higher end codec support within that, so some big improvements there. With regards to WebRTC, we actually have many players across Microsoft that engage there. So we've begun doing some work with perfect negotiation, which I think you'll hear about a little bit more from Mozilla. Screen capture performance and functionality improvements, and then also trying to fix WebRTC bug fixes. A good example of this is some of the ICE candidate errors that occurred upstream. So for the roadmap going forward with RTC, basically one of the things that we continue to hear about, I was just speaking with somebody here, is that it feels like all media and RTC stuff is a massive black box. So figuring out whose problem is where and what. We're beginning to look into how can we potentially expose a lot of very low information. Obviously there's a lot of privacy concerns. I actually feel like that's going to be the hardest problem that we face. But we engage with a lot of top partners a lot of times, and they get the benefit of us being able to talk to Intel about driver issues and all those other things. And so helping expose that in some way, in a meaningful way, but also ensuring that the user opts into allowing a website to have that capability is something important to us. Going and fixing some of the top RTC bugs that maybe aren't being focused on by other Chromium community members. We're very interested in investigating web transport and lighting up AV1 support on top of RTC. And then ultimately web codecs, and then in addition to that, and kind of in tandem, is the web inference API. Excited to hear about a lot of the AI stuff here. And then with regards to media, again, I kind of bridge the gap here between the two. We actively have a proposal for client-side video editing, because currently on the web, video editing sucks. And then media capabilities, which is a common request to be able to ensure that you're serving 4K, HDR, the content that is only necessary, understanding the output devices, or when they switch, for example, with Dolby Atmos, being able to serve spatial audio or not. Then audio offload, which is another, again, battery benefit. We're working closely with the Chromium open source community on that one to upstream that one. Sound categories, which allows you to do different echo cancellations and stuff of that. So when you get the user media, they can select the different sound categories. And then also web codecs to allow access to raw frames. So that's my quick run through. So thank you.
Hi, I'm Yuan Fablé. I'm part of WebKit team, Apple, and working on WebRTC. Today I present our journey towards WebRTC 1.0. It's at the top of a mountain, so it's not especially easy, but it's very rewarding. So let's see the progress made so far. Since last year, we added a lot of things like VP8, simulcast, unified plan, script capture on macOS as well. So I believe that now is a great time for actually trying Safari. If it's not already working, it should be very, very close. If it's not very close, come to me. But I really think that we are meeting almost all requirements for conferencing systems. But we are not yet at the top of the mountain. We still need to make some progress, and we are. In Safari Technology Preview, you can have some nice improvements, DTMF, proxy supports. We actually recently resynced our backend, so new APIs will come. So if you are still tweaking SDP and so on, you should be able very soon to stop doing that in Safari and just use plain JavaScript APIs. Great. OK, so let's say Safari is almost at the top of the mountain. That's sort of great, but when I'm talking with you, some of you, I feel like you have to climb the mountain for Safari, for Chrome, for Firefox. So it's like 4 mountains, and that's not great. But we also know that in Safari we have our own specificities. For instance, we are filtering private IP addresses. When you call enumerated devices, we are also filtering it very strongly for privacy reasons. We also have like very strong rules related to user gesture. So if you're trying to do screen capture and there's no user gesture, the call will fail, for instance. And until a couple of months or so, or years, it was very Safari specific. So we went talking with the other browser vendors to see whether we could converge on all these specificities. And we are making great progress there. So for this specific Safari behaviors, I would believe that if you are passing now, so if you are supporting Safari specific specificities, it should be good. You should be future-proof for future evolutions in other browsers. So hopefully, we will be all at the top of the mountain very soon, and we can all relax. Except maybe we should shoot for the moon, right? So let's see what you can do. There are plenty of APIs. I will just select 2 of them, speaker selection and image processing. Both of these APIs are really useful in WebRTC land, but they are also useful in other territories, like plain video streaming. Speaker selection is great. You might want to use it in conference systems, and it's working now in Chrome. But if you want to use the same API in YouTube, for instance, it's not working. It's not working because of privacy issues. And we are actually developing a proposal so that we are augmenting the current API called setSyncID with another API to enable a user to call this API. The browser will show a picker presenting all the speakers. The user will select it, and then the web page will be able to say, OK, this video element will go to this speaker, and so on. So we really want to go there. Another one is image processing. So currently, we are very interested in capture, transmitting, and in the middle, you cannot really process images. You can do it with Canvas, but it's very slow. Image bitmap and Upstream Canvas are being implemented in WebKit and are 2 basic primitives that should allow much better performance there. So we are really looking at these primitives to come and all the things you could do with them. And finally, I'd like to talk about testing, because maybe you're on the moon and you do not want to fall off. So you really need a good rope that will help you keeping safe. So testing, yeah. So maybe if you don't know it, you can check Kite. It's an open source project that allows to do interoperability between different browsers. There are other frameworks, and they're usually based on WebDriver. So I'm very happy to say that there is now iOS native WebDriver support, which means that you can run your websites and all your automated testing on real iOS devices. We are also thinking of adding new WebDriver media capture extensions so that your WebRTC testing will be even better. And that's it for me.
Hello, I'm Niels Omeyer. I'm an engineering manager at Mozilla, working on Firefox, and my team is responsible for the WebRTC implementation in Firefox. Today, I wanted to give you a brief overview of the things we're working on more in the background of the browser, but also give you a little bit of an overview of what's coming next soon. But let's first start with a public service announcement. TTLS 1.0 is 20 years old. All the browsers have agreed to turn off TLS 1.0 and 1.1 in March 2020. And as you can see, the usage of TTLS 1.0 in WebRTC is really low. It's like 1.8% last time we measured it. So we want to turn it off as well. So please, if your service still depends on DTLS 1.0, move to 1.2. It's required by the specs. It's like it's supported in all browsers, so hopefully it shouldn't be a big deal. There's a blog post giving you more details on how to do it and how to help with testing and so on. With that, on to some of the work we're doing in the background. So this is some data around like a use case. One of the bigger WebRTC vendors actually reported to us where Firefox was performing not very well in an 8-party group call. It turned out that that company had written JavaScript code, which was, let's say, not optimal. But nevertheless, it resulted in basically the audio in Firefox 61 glitching quite often in this 8-party conference. And so we went onto a project to heavily optimize how we process audio. And as you can see, over 10 versions, like the graph you're seeing is basically the one on the Y scale is basically the maximum amount of time we have to deliver the audio frames to the operating system. So in 61, you see like we're like at half of the time roughly. So as soon as you overload the browser a little bit, you will get like audio glitches, right? And so if you compare that to like 71, like we're like way further down, so you can put like a lot more load on the browser and it will still not glitch on the audio side. And with that, on to what's shipping right now. My colleague Janivar did some investigation into how perfect negotiation would look like, and he found like some new APIs, like Restart Ice is, for example, one, which helps with covering some edge cases. And Fippo already talked about MDNS shipping now in Firefox. And then currently in the works is SetSyncID, which probably has been mentioned here before as well. So that allows you to select the output device for your audio. And we're first going to ship that for WebRTC, and then we're going to tackle it for web audio as well. And then we're actively working on making the transceivers more flexible and more powerful. We shipped like the first implementation of transceivers, but we're like a little bit behind on the spec. So that's coming. And then for 2020, we're also committed to support these transport objects and provide simulcast-aware stats. And I can't leave the stage with like repeating my mantra when I go to WebRTC events, please test with nightly. If you're testing with release and you report bugs, it's too late. And that's especially important because Firefox is going to switch to a 4-week release cycle. We used to be on a 6-week release cycle, so things are going to be getting faster and faster. So please test with nightly. And that's it. Thank you very much.
Hey everyone, I'm Tommy. I work on WebRTC and familiar with Chrome as well. So there are going to be a few talks about WebRTC and what we're up to later today. But I wanted to kind of touch a little bit on the progress on the stuff that we presented last year, and focus on a new process model that we've introduced to Chrome, and basically we've landed a new echo canceller and the impact of that. So for echo cancellation, we've this year seen a huge improvement, and we've introduced a new echo canceller to Chrome and WebRTC, the library that drastically improves the situation. So the goal of this was that basically a year ago we decided that now, like this year, is when we're going to basically be shipping 1.0. And 1.0 means APIs, but it also means everything that powers those APIs. So we want to basically ship a polished enterprise-ready Chrome, and that we decided to take on a few like big challenges, such as introducing new media processors to Chrome and shipping a new AEC, acoustic echo canceller. So there are a number of problems that an echo canceller needs to deal with. In the case of Chrome, like in a situation like we're in now, you might have a device running, controlling the speaker, a completely different device controlling the microphone, different sample rates, so on and so forth. And this is a very hard thing for an echo canceller to deal with. And then you have like your laptops, you have your mobile phones, and even like across all of these devices, there are like multiple types of mobile phones, multiple types of laptops and desktops their operating systems, and so on and so forth. So in order to understand how well are we doing, we developed a component that we shipped with like Google Meet and Duo to understand how are all of the echo cancelers performing. And this was like an AEC agnostic component that detected echo, whether you were not using a native echo canceller or ours, or like the AEC that's available on Macs. And we tested the one on Windows as well. And throughout all of this, tweaked our own and iterated pretty quickly, and subsequently made huge improvements in echo cancellation across the board. And this was also like a good testing stone for us to be able to see how useful can WebAssembly be for us. And it turns out enormously useful. And yeah, so this echo detector component basically was key for us to land these changes. And the second big change that we did was introducing new media processors. So we've taken audio processing out of the Chrome browser process, which is basically the root process. And we now start this process on demand. We recycle it when we can. If we detect hangs, we'll basically kill and restart that process, which has been a problem. Sometimes you don't want to restart the whole browser if you can't access the microphone, that sort of stuff. And by taking all of this code out of the Chrome browser process, we also improved the stability of the platform. I think crashes on some platforms went down by as much as like 3 to 4%. And in some cases, such I mentioned here, Mac, by taking the audio processing calls away from the main UI thread into a separate process, we also reduced jank. Yeah, so on and so forth. You can try this out, because this was a pretty hard change to land, because besides WebRTC, everything in Chromium uses like the audio path. So today, if you run Chrome and you play a YouTube video, and you go and look at the little task manager, and you find an audio utility process now, and you kill it, it'll get restarted straight away, and you'll hear like a few hundred milliseconds hiccup, but things are fine. So we restart automatically on the first crash, but after that we report an error. And yeah, so this is kind of what's been keeping us pretty busy. We decided to focus specifically on the desktop case, because we were thinking about like enterprises. WebRTC should now represent a mature API, and it should be like the best of class experience. And now that we're there, we're taking a look at the next version. What are the things that we can deliver for WebRTC? And there are a few different components that we want to enable. But most of all, we want to empower applications to bring their own WebRTC, own components, and be a part of the experience. A lot more tweakability, and being able to manipulate pixels if they want to before encoding, or add additional application-level encryption, for example, if they want post-encoding. So for that, we're starting to work on WebRTC insertable streams. And being able to have machine learning trained components as part of the application is key. We're also preparing WebRTC, the library itself, to make this a little bit easier for developers. And we're trying to modularize things so that you can more easily pick a part of WebRTC and build a WebAssembly component that has that functionality, ship with your application without having to pull in all of WebRTC. So we don't want every application to be shipping WebRTC, the whole library. But that's, in a few minutes, basically what we're doing. So with that, I'm going to go and grab a chair. See you in a moment. Thanks.
Good. So, thank you all for your lightning talks. Actually, Tommy, you mind scooting in a little bit, just so make sure we get you on camera. So, those guys, in all those talks, so I didn't hear anyone reference to mobile at all. But maybe we could talk a little bit about what your thoughts on mobile browsers, perhaps slightly related to like WebView in there too. Niels, why don't you go first?
So obviously, mobile is a pretty important space, and what Mozilla is currently working on is basically replacing our Firefox for Android with something called Gecko View. And basically, the idea is that you get something like WebView, but instead you have the Gecko rendering engine. So you can build your native apps on top of that. We're shipping a browser built on top of that, and it's like fully supporting like WebRTC. So that's what keeps us busy right now in the mobile market, and iOS. Well,
Okay.
hopefully we will one day be allowed to ship like Gecko.
You want me to answer?
Yeah, maybe on that topic too, you and obviously mobile's pretty big for Apple, so like
Yeah,
there.
definitely. And so that's why I'm so glad we shipped iOS native WebDriver support. Related to WebRTC, one big piece that is missing and is asked a lot is get user media outside Safari. So I was very happy that we shipped get user media access in Safari View Controller, so that you receive an email, you click on the link, and then you can actually use the camera from it. So that was really painful, and now it's fixed. Next step, maybe some of you saw that we tried to ship get user media access on home screen web apps, and it almost shipped, but it was not yet ready, and we are actually working a lot on it. So I hope we will be there soon. Now the next step after that is actually WebP WebView. We really want get user media to be available for in WebP WebView clients, and it's not only for Gecko or Chrome, although it's very important. It's also, as we heard in the previous presentation, WebRTC forks are dangerous, and we have a good WebRTC fork in WebP WebView. It's being updated. It's secure. It's very secure also because we have a multi-process architecture that gives a lot of security benefits. So we would like people, native app developers, to actually use it, but they cannot because of get user media. So we are working on it, and I really look forward for the day where people will actually start using it.
Tommy, how's Google and Chrome thinking about mobile?
So for Chrome, this year we were focused on desktop. We were thinking about specifically the enterprise use case, so that was where the focus was for Chrome. But most of the changes we do in Chrome also make it to the mobile browser. And you can, for example, today do a dual call if you want to. If you force desktop in Chrome on Android, do a dual call through the browser. So like everything is working there. However, if you compare the performance, like the native app works better, like it's faster. So there, I kind of have to wear two hats. Like there's the Chrome hat, there's the WebRTC hat.
Yeah.
And on WebRTC, we have been focusing a lot on mobile. So there are.
But from a native perspective.
From a native perspective, and this is both for. Sorry, I shouldn't say both. I should say this is for Android and iOS. We've been focusing on Android and iOS, and we made a number of improvements there. And there's basically so much work to be done there that we've decided our browser efforts will be focused on desktop.
Okay. And I guess Greg, as the relative newcomer, anything different?
So primarily, I can actually echo what he said with regards to the Chromium work. Like we have a major client in Teams, and they primarily use on iOS and on Android the native RTC stacks. But we also do, from an edge perspective, desire for the capability to work kind of everywhere. And so from an edge RTC perspective, we're kind of doubling down on the PWA solution and path. So that's primarily where our focus is, because I don't know if you all saw, we do have some new form factors that are primarily more mobile-based. And so we do desire for everything to work just great everywhere.
Yeah, that's just you bring up a good topic, PWA. Why don't we, in progressive web apps, why don't we talk about that a little bit? You have anything else to add?
Yeah. Like we really want to close the gaps. We're engaged heavily with Google and Project Fugu and Intel to be able to bridge those gaps so that all the web properties that we work with, including ones that are using RTC and get user media and all those wonderful media-based solutions, are able to effectively write once and have it installed as an installable app and get those great experiences on Android, iOS, the new Surface devices, HoloLens, Xbox, all the different form factors that we ship to.
You want to add?
Yeah. So PWA is very interesting. PWA is basically a web page, but you no longer have the UI, the Safari UI that is there. And so it's usually fine, but when you're thinking about APIs like get user media, Safari is very cautious about providing the indicators and providing easy access to mute or unmute cameras and so on. In PWAs, it's gone. And there's the feeling that you are like a native app being trusted. But it's not as trusted as a native app because the native app was actually reviewed in the App Store and so on. So it's a different kind of hybrid model. And so the challenges there are really high to actually meet both security and the ease of deployment. So it's really a topic of interest, but needs a lot of thoughts.
Niels?
Yeah, I mean, I'm probably not in the official capacity to say like what Mozilla's position is on PWA, but I know that there's people who really like it inside Mozilla, and then there's folks who have like some concerns about privacy and so on. On the other hand, like to echoing what Yuan said, I think it would be better from a market perspective if like basically we spend a lot of time on like making our architecture like secure by like moving like networking into a separate process so that if your application gets taken over, it's like the attacker is confined in a enclosed space and stuff like that. So from that perspective, it would definitely be better if like people would be able to use WebRTC from a PWA rather than like shipping their own version of WebRTC and having to maintain it. So there's definitely benefits to PWA, especially in the space of WebRTC where things are pretty complex.
Okay, but no official Mozilla.
No, I don't think that
PWA
I'm
support.
entitled to.
I guess, and then
Me
we hope. Yeah, maybe tell me what what's the Chrome angle on PWA? It's obviously very big. I guess I'm curious specifically around WebRTC support within PWA.
So like we're completely on board with Chrome's vision for PWAs. In some ways, like it's in my opinion, it's like a platform versus product decision. In theory, like all PWAs should run on whatever PWA platform you have the same way. But like not everybody has all the same functionality. So you basically have to place your bets today on the browser that supports the platform you can run on. So today, like if you open Duo in Google Duo in Chrome, you get the install button and you can install it as a PWA and it runs fine. On mobile, if you open up Duo, you get redirected to the app itself.
Okay.
And that's kind of like a product decision. And yeah.
But on the desktop, it actually is doing get user media and the whole thing within the PWA. Nice.
Yeah.
Another topic I guess I'd like to transition to, last year actually our whole event was devoted to AI and machine learning. It's obviously a major factor in all computer science and where things are going. I'm very curious how you are incorporating both like machine learning processes into your own development to improve WebRTC and communications, and then maybe secondarily, it's kind of how do you interface with other AI type apps capabilities, things like speech analytics, transcription, computer vision, that sort of thing. So maybe Greg, I'll let you go first.
Sure. Our teams that work on the RTC stack, like we have Skype and Teams, they do all kinds of wonderful things within their stack to improve call quality and make it so you can hear them well and directional mic and all that good stuff. Another thing that we're heavily working on is actually we've seen some really good benefits for the prototype that I referenced in there, the inference access to the hardware under the hood, because all of us have, like Apple has Metal, we have DirectML, and we get access to the hardware that actually exists that's just for inference. And so we're heavily interested in figuring out an API to expose to web developers that they can end up using. We're working closely like with TensorFlow.js and other industry leaders in order to try to come up with an API that would allow you to, within RTC, like blur the background, but utilizing the backends that are there rather than just shoving it, for example, in WASM or WebGPU, passing it off to the OS to allow it to have that same performance benefits. And as I was telling them, we compared like what WASM and a WebGPU backend, and I think one of the scenarios was as high as close to like 3,000% performance improvements by utilizing the hardware that was there. So pretty excited about that.
Yeah. Tommy, I'll let you come in next.
Can you repeat the original?
I guess the question, how are you incorporating machine learning both within to your development, optimizing the WebRTC stack and also just leveraging that to interface with other machine learning applications, use cases like transcription, just as an example, or computer vision?
I guess there's no one answer to it. Like, it depends on what the target is. Like, you could be using it to upscale video, for example, or you could be using it to adapt to different network scenarios. Doing packet concealment, that sort of thing.
Yeah, and have you looked at using machine learning, say, to improve the bandwidth estimation or something along those lines, or?
Yeah, absolutely.
Right. Niels, I should say too. I mean, Justin Uberti, who will be up speaking later on, gave a really good demo last year using Mozilla is one of the backers behind RN Noise for noise cancellation, right? I mean, that's a kind of example of how, right, maybe you're not incorporating it directly within the browser stack, but you're exposing methodologies so you can utilize some of those capabilities. Yeah.
Yeah, it's on our to-do list to look at whether we can incorporate that into Firefox, but then how to expose it.
Yeah, maybe repeat. I don't know if why don't you repeat it? I don't think you can throw in the
Yeah, we're looking at how we could potentially incorporate that into the browser directly into the WebRTC stack. But in general, my group is not the group within Mozilla which looks at machine learning. There's emerging technologies, and they're looking at that. They're, for example, working on web speech and working on using machine learning there. And obviously, we're working pretty closely with them to whatever they find, incorporate that back into the browser.
Right. You made some references in your talk too. We can elaborate on those.
Yeah, image processing. So some of you may have seen FaceTime eye contact correction, for instance, and it's fine, and it would be great to have that being feasible in a web browser in an efficient way. Currently, this is done using ARKit, and it's great because there's a tight relationship between the code and the hardware. And that's something that is very important to get for scalability and efficiency reasons. And I really encourage APIs being designed with that in mind. That's really important.
I totally agree. It's putting everything in the platform is
there's a trade-off, of course.
Yeah.
Mm-hmm.
It's great to experiment in JavaScript, for instance. But at some point, if you really want something that will be full speed, super efficient, you need the help, and you need the help of the platform. H264 in JavaScript is feasible. I wouldn't recommend it.
I'm curious. Well, and I guess Niels, well, picking you first, since you don't have any underlying hardware substrate you can take advantage of that Mozilla controls. I mean, how do you think about hardware acceleration and some of those capabilities, and how do you consider that when you're thinking about features and things that go inside?
Yeah, that comes with it's a double-edged sword for us, in the sense that we're the browser which has problems with licensing, right? We cannot license H264. We would go bankrupt basically if we would do that. So because of that, hardware acceleration is actually an advantage for us in that sense that if the platform provides it, we don't have to worry about H264 licensing, right? So from that perspective, it's very important because the software side, shipping, we cannot ship a software decoder because then again we would have to pay license fees. And in general, I think I totally I'm with you and there that where you have the hardware, we should probably think about how we can expose that and make it available, rather than trying to move everything to WebAssembly. I mean, WebAssembly is a great tool, no question asked. But basically investing in making that faster and faster and faster and leaving the hardware on the side doesn't really make sense, right?
Same thoughts that.
That's actually the community group I was referring to. That's precisely the goal, is coming up with the model formats that make sense that you all want to run inference on, and ultimately leaving it up to the OS to say, okay, you've passed me these things in a logical way and a good API design, and now I'm going to go run this on the TPU or GPU, whatever backend makes the most sense, and it could be CPU. But ultimately, yeah, utilize that hardware that makes sense for the given use case, so you get the answers as fast as you can to do great background blurring at scale on these wonderful RTC clients you're building.
Although you you then need to start thinking about like when you utilize the hardware, like you will probably end up running into problems of like, hey, I'm running like a call with like 4 video streams, like I ran out of hardware decoders, what do I do now, right? Do I reject more further video streams, or do I now turn on my software decoders, right? So probably even if you utilize the hardware, you might need to still have the software there as a backup if the application demands more. Right?
And that's precisely why I think, to your point, we wouldn't expose a ton of like JS primitives. You wouldn't want to go that route, because the OS then does know when you've reached a limit, and it knows which path to go take. That JavaScript unfortunately doesn't have access to.
There's one other topic I wanted to cover too that we don't cover enough, that I'm happy that we had Natalie cover too, and that's security, right? And I guess there's general issues and things, I guess processes that go through the browser, and then as Natalie exposed, there are WebRTC stack specific items that come up. Maybe Tommy, I'll let you comment on that first.
I'm not sure which part you want.
Well,
we do.
Yeah, I mean, how do you think about testing WebRTC specific?
So we do fuzzing
issues
a lot, and we're always doing more. And I actually remembered that code snippet, which she showed earlier, and it wasn't caught by our fuzzing, but we're improving it all the time. In terms of runtime security in Chrome, for example, even though we were taking some of the audio bits that previously were in the browser that I was talking about before, it was important for us that as we move those out, we take the opportunity of sandboxing that. Because what we're seeing, especially for audio on Mac and Windows, is that there's a lot of third-party components that also kind of participate in that chain. And sometimes they might be the cause of a vulnerability, so we wanted to just sandbox it. So security, obviously, very, very.
Okay, maybe you, and I'll let you go second.
Yeah, I fully agree. Fuzzing is great, writing good software is great, but at some point you will be hacked. So it depends.
Mic drop.
The point is, you will be hacked, but maybe it will be in a process that has nothing to do except boring things. So you will see this process, it's corrupted, but it will not be able to get root access or whatever. So that's why sandboxing is very important. For instance, for our implementation of getDisplayMedia, we could have done that in the process that is running JavaScript. But this process is really, really untrusted, and that's the one we are sandboxing as much as possible, and we are continuing to do that. And there we decided that the work to actually capture frames will be done in a process that is fully secured. And we are fine with the cost to do some IPC to take the frames, send them to the web process. That's fine, but at least we're secure.
Yeah, we do something similar. We have an ongoing project where we move the networking processing out into a separate process, which will do only network processing, all the incoming protocols, because that's arbitrary data you need to parse, right? And that's basically what Natalie is talk about, all this data which comes in, you're parsing. These parsers are a big problem. And then it will end up in a sandbox, right? And we to echo that, we do also run our own fuzzing, especially on our code, not so much on the code we take from WebRTC from the Google guys, because we know they're fuzzing that already, so that would be just a little bit of waste of time. Then I mean, in my presentation, I talked about turning off DTLS 1.0. We also turned on the GCM ciphers for SRTP. So yes, we definitely care about the security ciphers and making the protocols as best as possible, as modern. And then there's the aspect of dealing with security around bugs and problems and that. And we basically work with the Google guys. The other day we found a crash in our automation, and we reached out to the Google guys and said hey, we think this actually affects all of WebRTC, up to we couldn't trace where it originated from, basically.
When you say you reached out to the Google guys, you mean you actually sent me an email?
Yes, yeah. Well, yeah, I mean we had it in our bug reporter, and we're well, I mean sure, we could just disclose it. Or just ship it in Firefox, but we're no, we shouldn't disclose it. We shouldn't just ship it in Firefox. We should basically notify the Google guys. That needs to be fixed upstream as well, and the community needs to fix it, right? That's another part of the security aspect, right?
Yeah, I really like this idea of community there. Like we discussed, for instance, the TLS and how to deprecate it, and we are doing that all at the same pace. And the same with exchanging security issues and improving the communication there is really really great.
All right, I promised Sadi, because I was hogging all the questions, I would give him one. So one question. We have to be kind of quick because we're cutting into lunchtime.
From me,
Yeah, from you.
from the audience, debugging tools for developers. Who are we that? I mean, Chrome has the best out there. It can be improved, but the best. What about the rest? Just,
Yeah, you want to defend that comment?
Yes, I definitely like the live graphs and like the Chrome internals. We're struggling a little bit to. Unfortunately, I don't have like any front end people in my team, which could do like the representation as nicely. We do have like about WebRTC, which has like a little bit of a different focus than the Chrome internals. We do have also an extension to our developer tools, like an add-on you can download specifically around media, and so it covers basically like the classic playback scenarios, but it also covers like WebRTC, so it gives you like the like a tracing of like the API. So it's definitely a topic which is on my mind, especially since I think. Hopefully we have left like connectivity and these kind of things like a little bit as the problems in the past, and now we're moving more to like quality issues, like why did the video quality degrade in the middle of the call, that kind of stuff. It's pretty hard to find out, even for like browser developers. It's like non-trivial right now, and like there's definitely a big need to like come up with good ideas and improve in that area.
I definitely have opinions and hopes for this because we meet with media folks, like you said, that they're very much overlapping. And I wouldn't even necessarily say it's actually in a tooling perspective, because they range so wildly. Like when we work with some of the larger media players, they have a bunch of like failures, but they don't actually know the reason why. And it's not like they can actually just go pull it up on their Mac or Windows PC and actually repro the issue, because it ends up being some device that they don't actually have access to, and it ends up being like maybe like a driver was corrupted or some other scenario that there's no way they could even address. And so I would love to look into, now granted this has all kinds of, to me the largest problem with this is actually coming up with a privacy model that makes sense. Because ultimately it's super unfortunate that web developers is just a massive black box when it comes to media. Like even if we end up saying you dropped 1 million frames, why? Like that's not helpful. We just told you that it's a problem, but it's no help. And so like we wouldn't, if I came to Mozilla with a bug and said, basically, hey, you got a problem, you would be like, cool, that's not actionable. And yet that's kind of the state that it's in. And so we need to figure out a way to effectively give you symbols so you can actually debug enough information so you can maybe go out and buy a $100 Android device if that ends up being the case. Or at least enough information you can begin trying to address the problem. But again, like I said, the biggest problem that's going to face is figuring out a way to do that in a private and secure manner.
Any other, about 1 minute for any last comments on that topic?
I just wanted to say, like, I think WinDebug is probably one of the best debuggers out there. So WebRTC also has event tracing built in, so you can actually, if you're using WebRTC natively, let's say on mobile, there is a way to use the event tracing facilities in WebRTC, export the file, and use the Chrome debugging tools to see, the threading of your application, even though it's not Chrome. Just FYI.
On Safari, you can also enable WebRTC logging, very extensive logging, and it will appear in the console log. And it's probably fine. It's not as good as Chrome internals, but it gives tons of information, which allows you to debug if you have the device. But I agree, usually you don't have a device.
Yeah.
And you get some WebRTC stats, and you're like, what can I do?
Cool, yeah.
It's
a hard problem, though.
It's a very hard problem, yeah.
Mm-hmm.
Right now, I'm like usually is like, hey, I have actually like another company which is like facing some problems. And like, yeah, I think what you're describing there is like heavy packet loss. I think your end is not retransmitting the packets, but like the only thing I can tell them right now is like turn on the RTP logging, load it into Wireshark, and confirm that your server is actually resending the packets, right? Because we don't have really good tools to easily make that accessible and like make that easy for them to say like, oh yeah, my server actually did resend it. Why did Firefox still think it's missing?
Unfortunately, we need to bring this to an end. I know if we open it up to audience questions, we'd be here till 5 o'clock, probably later. We can't do that, unfortunately. I do want to thank you all. This is really awesome. It's so great that the whole WebRTC community, we can come together and have a conversation like this, so I really appreciate you being up here.